Assalamu alaikum. So my name is Abuzar Bharuchi, and today in this video I am going to teach you trial division primality test part 3, and hopefully this will be the final part of this trial division primality test of this test. So before moving further, to I want to quick give you quick recap of what I have taught in previous part 1 and part 2. So in part 1 I have reminded you of the definition of factors, definition of prime numbers, and how to check a number is prime or not. In part 2 I have given you some observation number 1, and that is, for a number n there cannot be a number greater than n by 2 to be a factor of that number n other than n itself. So and in this video I'm going to teach observation number 2, which will be the final and concluding step over this test. So let us move on to observation number 2. So observation number 2, let me take some 3 to 4 examples. So first I will give you some examples and then I'll prove you later. And I want to emphasize on this fact that this observation number 2 is hard to understand, so listen it very properly. Okay, so 36, first example is, so 1 times 36, 2 times 18, 3 times 12 times 9, 6 times 6, and then 30, 12 times 3, 6, and 9, 6 and 6. 36. Another way of showing factors is this. In this way, we can show it in pairs, so that is very efficient. So what I'm trying to say is that if we take a number that is not a prime and we divide that number with one of its factor, we will get another factor. And in case of a perfect square, that another factor might even be the same factor. Let me tell you some example to teach you what I was saying. So example 30. When we divide 30 by 10, we'll get 3. So you can see that 10 is also a factor of 30, as it's dividing 30 completely, and 3 is also a factor of 30. 30 divided by 3 is equals to 10. So you can see, when we divide by one factor, we will get another factor. And in case of perfect square, in case of 36, when we divide it by 6, we will get another factor to be the same factor as previous one. Okay, and in this case 36 divided by 9, so we might even get some another factor in case of perfect square also. So what I am trying to say is, my friends, that when we take 2 as a factor of, or let's come to example 30. When we count 2 to be a factor of 30, we automatically count 15 also, because when we divide 30 by 2, we will get 15. Or we can also do that if we count 15, automatically 2 will come into account, that is this. So what I'm trying to say is that when we are able to achieve this step, that when we count 1, we automatically are counting 30 also, and when we are counting 2, we are automatically counting 15 also, and when we are counting 3, wait a minute, 6, 1, 10, 3, 15, 2, 30, 4. And when we are counting 5, we are automatically counting 6. So we have already covered every pair, because when we will move further and we are counting 6, we are already counting 5, we are also counting 5, but this pair is already be counted here. And similarly, if we go for or further and we count 10, we will automatically count 3 also, and this pair is also will counted here. So you can see that we are, if we go from 1 till up till 30, we will take every pair, then that means we are counting twice. So in order to avoid this, we will go for such a number that if we reach that number, all the pairs of factors are covered. And that number in case of 30 is 5. That if we go from 1, 2, 3, 4 and then 5, as soon as we reach 5, we will cover every pair of factors of 30. So now we don't even have to go for 30 divided by 15, because in observation number 2, I have proved you that for checking a prime number, we have to go for 2 to n by 2. And in observation number 2, by taking this observation, that we do not have to go till 15 also, because this pair of factor is already being considered here. So we'll go till that pair. For when we reach there, all the pair of factors are being covered, and that in case of 30 is 5. In case of 36, it is 1, 36, 2, 18, 3, 12, 4, 9, 6, 6. And by moving further from 6, that is 7, 8, 9. As soon as we get to 9, we will get the same pair of factor as we have counted before. So in case of a perfect square, we will stop at, in case of 36, it is 6. So in case of perfect square, we will stop at n square. If this is a perfect square, we will stop at n. In case of 25, we will stop at 5. And I will prove you this later also in this video. So for perfect square, we will go from 2 up till square root of n. So you can see that what you have seen in the code of this program, this test, you have seen the loop running from 2 to square root of n. So this is the example which I am teaching you. In the later half of this video, I will also give you some proof. And in case of 30, which is not a perfect square, we will stop at 5 only, because square root of 30 is 5 point something, and we are talking about natural numbers, so we will stop at 5 only. So in either of the case, we have to go. In the case of 36, root n is including, but in case of 30, root n is excluding. But in either of the case, max to max, we have to go from 2 to root n, both including. And now let us move on to proof. If you have understood and you are convinced by the example that we have to run the loop from 2 to square root of n, you cannot watch the later part also. So let us assume a number a which belongs to 2 to n minus 1. But since I have told you in part 2 that there will not be a factor which will be in the range of n by 2 up till n minus n by 2 up till n. So we know that from n by 2 up till n, there will be no factor of any given number. So we'll not go, will restrict its domain or range, you can say, from 2 to n minus 1 up till n by 2, because in this range it can be a factor of a given number. So now if a, we have taken assume a number a which belongs to 2 to n by 2, and let's say that a divides n completely, a is a factor of n. So that means when we divide n with a, we will get some another number, because I have seen you showed you in the example also that when we divide 30 by 10, and if 30, since 30 is not a prime number, we will get, and since 30 is not a prime number, 10 is a factor of 30, and we will get another factor also, that is 3. Same here, when we divide n with a, and if a is a factor of n, then we are talking about all this. So when it will be, we'll get another factor of n. And when we divide n with b, we'll get a, another factor of n. So we are getting one pair of factor in, that is a and b, in that pair. So that means when we multiply a into b, we'll get n. And since n is some constant value, that means n can only be produced when, if a increases, then b has to decrease. This is basic knowledge from our lower classes, that when we have to produce 30, we can produce it by 2 ways. That is 2 times 15. That means a is smaller, then b has to be bigger, so that product comes out to be this much. And another kind of way is 15 times 2. That is, if a is bigger, then b has to be smaller, because when both will be bigger, then this would not be achieved. So for a constant value, and we have two things in product, we will always see that if a is bigger, then b has to be smaller, so that n will be some constant value, and if b is smaller, a has to be bigger. This we learn in basic also. By understanding this, I am saying you that since both are the factors of n, so why not only focus on one, and that will be sufficient for us to know that whether n is a prime or not. For example, when we take 30, we get 1, 30, 2, 15, 3, 10, 5, 6, 5, 10, 3, 15, 2, 50, 1. Now let us suppose that the number on the left hand side is a and number on the right hand side is b on a number line. So you can see we are going into very much basic also. 1, 2, 3, 5, 6, 10, 15, 30. So you can see, as I have said, that left hand side is a and right hand side is b. You are just considering. So that means a is first, it was 1, then it became 2, then it becomes 3, then it becomes 5. So you can see that a is keeps on increasing. And for b, first it was 30, then 15, then 10, then 6, then 5. So it is keeps on decreasing. So as you can see that when we increase a and we decrease b, at some particular instances, for example, when we come to 2, we are automatically counting 15 also. That means when we are increasing for a and decreasing for b, at some particular instances, we are getting our required number, that is 30 here. So we need to check what is that number. For when we reach there, we are covering every pair of factors of the number 30. So that we have to see for the, and in this case it is 5, as I have showed you previously also. In this case it is 5, that if when we reach to number 5, we are covering this factor, this pair of factor also, and this pair of factor also, this one, this also, and this also, this also, and this also. And when we go till 5, this is also been automatically be counted in the pair of factors. So in this case it is 5. So basic observation is this, that every pair is being covered when we are coming onto middle. So for primality test we have to check from 2 to that some middle, and now question is, what is that middle one? So let's say that when we increase A and we are decreasing B, at some particular instances, it is not the case in example 30, but in some another number, it can be some instance that when we are increasing A and when we are decreasing B, both meet at the same point and is giving you the and is generating you that n. For example, in 36, that 6 times 6 is going to give you 36. So when we are increasing up from 1 till 6 and we are decreasing from 36 up till 6, we are getting some value that is some middle part. In this case it is the under root of 36, and when we will get there, we will already cover all the pair of factors which have been there in the 36 number. So let me take you some by generalizing the result. At some point when we are increasing A and decreasing B for some number, we don't know what's that number is. I have taken you an example of 36, but there might be some other number also. So we are generalizing it so that we can get a rule out of it. So at some particular instance, A is equals to B. So now that means that A times A equals to N. So this implies A square equals to N, which is equals to perfect square. So in case of perfect square, we are getting, in case of perfect square, that middle number would be n equals to, or A equals to root n. And since A is that middle number, because we are not going further also, is because when we will move, for example, is the case of 36. So 1, 2, 3, 4, 6, 9, 12, 18, 36. In example of 36, when we go from here and when we go from here, when we increase A and when we decrease B, we are getting onto middle of this 6, and if we move further away, we will get 9, which we will multiply by 4, we will get 36. But that same pair, that is 9, 4, is being generated already here when we have gone from 1 up till 4. That when we have counted 4, our B was here at 9. So you can see we are not missing any pair. If you have some doubts that what if we will miss some pair, or that, I have showed you previous also, and by now taking example so you can understand more better way. So I have showed you that there will be no pair that will be missed out. So we are on the right track, that when we go from 1 up till 6, in case of perfect square, we will cover every pair, and by that we will see the primality test also. So in case of perfect square, we will go from 2 to square root of n for checking a number is prime or not, because in this only, if a number is not a prime number, we will surely get at least one factor, or when we are not considering 1 and n as a factor, so we will get at least 2 factor. If a number is not prime, we will get at least 2 factors which will show us that the number is not prime in this range only. In this range we will get only 1, and that will be, for example, when we take root 36, since 36 is a perfect square, you can take example of 30 also. We are checking from 1. We are not checking from 1, we are checking from 2, since 1 is a factor of every number, and so we are not counting the pair 1 comma 36. We are moving from 2 up till 35. When we are checking this, and in observation number 1, I have showed you that we have to check for 8 till 18 only, because there will be no other factor. So we are checking from 2 up till 18. So now in this observation I have showed you that we have to check till square root of n. So we will not even go from 7 to 8. We will only check that for number 6. So for any number which is not a prime, we will surely get at least one factor which will be in the range of 2 to square root of n, which will be sufficient for us to tell that number is not a prime number. And in case of non-perfect square number, a and b will never be equal, and since a is increasing and b is decreasing, so that means a will always be less than b, so that we will get a times b equals to n, because when this is less, this has to be greater. For example, in case of 30, when we go for 3, we will get 10. When we go for 5, we will get 6, and its square root of 30 is somewhere here. So you can see that a will be less than b in case of non-perfect square number. And in that case also, we will not going to check for square root of 30, but we are max to max in either of the case. If perfect square, then we are including square root of n, but in case of non-perfect square, we are excluding square root of n. We will get some, for example, in case of 30, since it is not a natural number, square root of 30 is not a natural number, we will not go for square root of 30, but a number which is natural before that square root of 30. In case of 5, we will go up till 5. That computer can also understand. So in either of the case, we will go from 2 to square root of n for checking a number is prime or not. Isn't that amazing? That how much we have saved our time, for us also and computer also, in our efforts. That we do not have to check from 2 to n minus 1, as I have tell you in the part number 1, and not also from 2 to n by 2, as I have showed you in part number 2. By this simple observation, that a and b will, when a is increasing and b is decreasing, we will always count 2 pair of factors. That is, we are already counting 9, 4, and again we will also count 4, 9. So we have to count only 1 because one factor is sufficient other than 1 and n, that a number is not a prime. So you can see this is very much amazing, and it is very much our time saving and effort saving also. That we have to check if a number is prime or not, we have to only go from 2 to square root of n, and if some number in between this range comes out to be a factor of n, then we can conclude that n is not a prime. And in case of prime number, this will not be the case, that from 2 to square root of n, we will not get any factor of n. So for example, I will give you so that I am convinced that you also understood. For example, 7, we will not get any factor between 2 to square root of 7. Square root of 7 is square root of 9 is 3, square root of 4 is 2 point something. So we will not get any factor. Even if we say that 17, we will not get any factor between the range 2 to square root of n. So this will be sufficient for us to tell that 17 is a prime number. And in case of 16, we will surely get so much factors in between 2 to square root of n. That is, square root of n is 4, so we will get 2. So first factor is 2 here. So when we encounter this 2, we will stop our process and tell that it is not a prime number, because it is not 1 also and it is not 16 also. So any number other than 1 in itself is not to be a factor is not considered a prime number. Okay, and I have to tell you one thing also, that if we take some very large digit number, for let us say 10 digit number, we are taking 10 digit number and we have to check that if that number is prime or not. For that type of numbers, this method will not be efficient, because still, or you can think of 10 digit number and taking square root of that 10 digit number, it will be around almost 5 digit or 6 digit number. So in that case, there are other methods also. So I hope you understood this process of checking by trial division primality test of checking a number is prime or not, and you have understood it. If not, you can watch this another time also, because it does not mean that you are dumb or something like that, but you can check it another time also. So hope you like this video, and thank you.